Good afternoon and welcome. We are glad that you could join this session where we're going to talk about defense in depth and zero trust network access. So zero trust network access and defense in depth are the two very major or very critical strategies which you can use to improve your security posture and protect your valuable assets like your networks and data. So in this session, we're going to talk about these two concepts and see how you can deploy this in your network to improve your security posture. Let's dive into it right away. So this is an overall agenda. We're going to start with talking about cybersecurity framework. We're going to talk about a few network protection use cases, and then we're going to talk about defense in depth approach, followed by some popular perimeter security architecture out there. And then I'm going to hand it over to Parichat, who's going to talk about zero trust network access. So when you look at a cybersecurity framework, we have these 5 sections, starting with identify, where we identify the processes, the systems, and the resources you want to protect. Then you look at the tools and techniques you have in your toolkit to safeguard these resources and these systems in your environment. Then you look at tools or techniques which you can use to deploy operational tooling to detect any anomalies in your environment. Followed by, if you detect an anomaly, you would want to look at tools which you can use to contain the impact of that incident by responding to that incident or the anomaly. And then you would look at tools which you have in your toolkit to restore your environment back to a good known state, right? So if you look at AWS, or if you want to align AWS with a framework, we have services for each of these pillars, right? For example, in identity, we have AWS Config and AWS Systems Manager. For protect phase, we have AWS Web Application Firewall, AWS Network Firewall, AWS Shield, AWS Firewall Manager, etc. For detect, we have Amazon Inspector, Amazon Guard Duty, AWS Security Hub. And once you detect an event, you can use AWS CloudTrail and Amazon CloudWatch to investigate these incidents. And based on the nature of the incidents, you can decide to remediate it automatically using AWS Lambda or AWS Step functions. And then you can use tools like snapshots and AWS CloudFormation to restore your environment to the last good known state. Right? So in this talk, we're going to focus on the services within the protect umbrella or the protect pillar. Right? So the services we talked about, you can use these services to protect these network protection use cases, starting with inbound or ingress, where your applications or your public-facing applications are being accessed by resources on an untrusted network. The next is outbound or egress, where your protected resources are accessing network or applications on the untrusted network. The third is lateral or east-west, where you want to secure the traffic which is flowing within your AWS environment or from your AWS environment to on-prem or on-prem to AWS. And last but not least, remote access infrastructure or remote work infrastructure, where your corporate users are trying to access applications protected in your AWS environment or in your data center, right? Now, all these use cases can be deployed separately or in a combined fashion. We call it distributed architecture or centralized architecture. I'm going to talk about that in the subsequent slides. So with that in mind, let's look at an overarching principle which we need to keep in mind when you're designing our architecture, which is defense in depth, right? So the idea is to use the services you have available at each layer to protect that layer, right, and get comprehensive defense in depth. For example, you can deploy your workload in AWS VPC. Now, Amazon VPC, and Amazon VPC is a virtual private cloud. It's an isolated virtual network you get on AWS with no ingress or egress paths to it, unless you specifically configure the routing table and gateway to it, right? So you deploy your application in a protected subnet, and then you configure the routing rules to bring traffic into it. But before the traffic comes into your workload, it has to go through AWS Shield at the edge, right? So at edge, AWS Shield is an anti-DDoS service which gives you DDoS mitigation against known layer 3 and layer 4 DDoS attacks. Right? Once it passes through AWS Shield, you can choose to send the traffic through AWS WAF if your traffic is web traffic, HTTP or HTTPS traffic. Or if it is non-HTTP, HTTPS traffic, you can choose to send the traffic through next generation firewalls like AWS Network Firewall and any third-party firewall which can integrate with Gateway Load Balancer. I'll talk about that also in subsequent slides. And between these firewalls and your workload, you would deploy application load balancer or network load balancer so that your application can scale seamlessly and be resilient on the back end. And at this layer, you can apply security constructs like network ACLs and security groups to further restrict the traffic coming into your environment. And now there are services outside of the VPCs which can be used to get comprehensive defense in depth. For example, Route 53 Resolver DNS firewall, DNSSEC validation, and for visibility, you can use VPC flow log, traffic mirroring, and Amazon Guard Duty. So keeping these in mind, this should be the overall, this should be always be used whenever you are designing your Ingress, Ingress inspection. And in today's session, we will be looking at AWS WAF, AWS Network Firewall, managed by Firewall Manager Service to build some Ingress architecture and egress architecture. But keep in mind that these architectures which we're going to discuss today can easily be deployed using third-party firewalls when integrated with AWS Gateway Load Balancer. Right? So let's look at what we mean when we say distributed versus centralized Ingress deployments. Right? So when we say distributed, what it means is that your applications are running in their individual environments like VPCs. In multiple applications are running in multiple VPCs. And each of these VPCs have its own individual internet gateway. That means path to the internet. And you deploy your security layer in each of these VPCs separately. And when the users are accessing it from internet, they access it through each individual VPC internet gateway and goes through the security layer you have deployed in each of these VPC. Versus if you look at centralized, the applications are still running in your VPCs, individual VPCs, but these VPCs do not have direct access to internet. Right? You deploy an edge VPC which has access to internet, and you deploy all your security controls in this single edge VPC. And when users are accessing your application, it's going to come to this edge VPC, get screened there using the security controls you have in place, and then it's going to hit the backend VPCs. So when we look at inbound inspection, right? That was distributed and centralized, and we looked at the the defense in depth approach. Now, keeping that in mind, there are a few more considerations you need to have before you decide upon what architecture you want to use for your filtering, right? So starting with the type of application you want to inspect, whether you want to inspect HTTP, HTTPS. If that's the case, you can use AWS Web Application Firewall. Or if it is non-HTTP, non-HTTPS, in that case, you can use any other next generation firewall like AWS Network Firewall. The next thing to keep in mind is whether your data plane and control plane is centralized or distributed. Right? And then you decide upon the inspection depth, whether you want to look at the traffic at port and IP level only, or you want to look at the application payload and make decision based on the content of the payload. And finally, you decide the scale, whether you are going to protect one VPC or multiple VPCs. Right? So now with these in mind, let's look at certain architectures, starting with distributed architecture using AWS WAF, AWS Web Application Firewall. So in this distributed architecture, you have your workloads running in the private subnet, which is fronted by a public load balancer, like public application load balancer, and it has a AWS Web Application Firewall attached to it. Right? And when the traffic comes in through IGW, it's going to go through AWS WAF. If it is allowed, then only it will hit the backend application. So this kind of architecture will help you inspect HTTP and HTTPS traffic, right? Because we are using Web Application Firewall. This web application firewall can decrypt the traffic. That means it can also look at your application payload, and you can get inspection depth at application layer. The data plane here is distributed because you're going to have a web application firewall for each of the Ingress VPCs or each of your workload. But you can centrally manage, you can have the control plane as central by managing it using AWS Firewall Manager service. Right? Now let's look at the same architecture, distributed Ingress using AWS Network Firewall. The difference here is that we introduce a AWS Network Firewall endpoint between the internet gateway and the application load balancer. And your workload is running behind on a private subnet behind that application load balancer. Then you tweak your routing table using Ingress route tables associated to IGW or your internet gateway to send the traffic through AWS Network Firewall. Right? So this kind of architecture will let you inspect any kind of traffic because we are using AWS Next Generation Firewall. In this AWS Next Generation Firewall or AWS Network Firewall can also decrypt traffic. This is a recent feature which we rolled out with AWS Network Firewall, and it's available in select region. We are slowly rolling it out onto other regions too. And because you can decrypt the traffic, you can do the inspection at application layer. Right? And like the previous architecture, the data plane is distributed because you're deploying it in individual VPCs where you have the ingress, internet ingress. But you can manage it centrally using Firewall Manager service. Right, so let's switch gears and talk about centralized architecture, how a centralized architecture should look like for this. So your applications are running in your VPCs, same like the previous one, but these VPCs do not have direct access to internet. You deploy your internet access in the edge VPC, and these edge VPCs and app VPCs are connected with each other using AWS Transit Gateway. So AWS Transit Gateway is your cloud scale, highly resilient, easy to use, scalable router, which makes networking within the cloud easy. Now, when you do this, in the edge VPC using WAF, you put an application load balancer, public facing application load balancer, and associate web application firewall to that load balancer. Then you have to point your application load balancer in the edge VPCs to the IP addresses of the network load balancer in app VPC, right? So that the traffic comes through Transit Gateway. And then when you bring the traffic in through WAF, AWS WAF is going to screen the traffic, and if it is allowed, it's going to use VPC and Transit Gateway routing table to get to the backend. Right? So the consideration here is when you're using is that the application load balancer can use only the IP address of the network load balancer in the app VPC. It cannot use the host names in the target group. Right? And the second thing is your applications which are running in your VPC should be fronted by a network load balancer so that we can use the IP address of the network load balancer in the target group of ALBs in the edge VPC. So let's look at the same architecture, but this time using AWS Network Firewall. As you can see, the only difference here is that you are introducing network firewall in the edge VPC in its own subnet between the IGW and the application load balancer or the network load balancer. Then you do the same thing as pointing the ALB to the IP addresses of the NLB. And then you tweak your routing table using Ingress route table on the IGW so that the traffic enters your VPC, edge VPC, goes through the AWS Network Firewall endpoint before it hits the backend workload. So we have the similar considerations which we need to keep in mind as the previous one, where ALB can only point to the IP address, and that needs to be NLB fronting your workload. So these were the centralized ingress architecture. Let's look at egress, like how do you do distributed egress and centralized egress, right? So starting with distributed, as the name suggests, each of the VPCs has its own internet egress. You deploy the firewall or the security layer in each of these VPCs, and the traffic leaving from each of these VPCs toward internet will go through these firewall endpoints, individual firewall endpoints. But as in the previous case also, you can manage all these distributed firewalls in multiple VPCs centrally using AWS Firewall Manager. And if you look at the centralized portion, like how do you do the egress filtering or egress inspection for centralized, the concept is pretty much the same. You have an inspection VPC or edge VPC with your firewall endpoint in it. all the VPCs on the backend are connected to the inspection VPC using AWS Transit Gateway. And you can configure the routes in such a way that traffic from VPC1 to VPC2 will always go through AWS Network Firewall, which will give you east-west traffic inspection. And you can also configure a route table in the inspection VPC in such a way that through NAT gateway and IGW, the traffic can leave out to internet. Right? So you get east-west as well as north-south traffic inspection. So these were the famous or popular architecture I wanted to talk about when it comes to ingress or egress inspection. Next, I'm going to hand it over to Parijat, who's going to talk about Zero Trust Network architecture. Over to you, Parijat.
So thank you, Vijay. Hi, everyone. My name is Parijat. I'm a senior solution architect. So today I'm going to talk about Zero Trust Network access. At AWS, we believe that Zero Trust is a conceptual model, that you shouldn't rely on just only network or network parameters, but you should also use non-network-based control, like identity or device posture to your application, and keep continuously verify every request that comes into your application, even it comes to the same application or it comes from the same user. But in traditional way, it's quite complex if you want to implement Zero Trust solution. You might need multiple teams to manage security in each layer. For example, you may need network team to manage VPN policy. You also need developer to integrate your application to your identities, right? And you also need IT admin to manage device policy and allow only compliant device to access your network. As you can see in this example, there are at least 3 sets of policy that managed by 3 different teams. And imagine that if you want to change policy or add new application, it may take days or weeks, right? With this feedback from our customer, we just announced AWS Verified Access in the reInvent last year, and it's now available on the selected region. With AWS Verified Access, it gives user an easier way to connect. Your user can access your application from anywhere. Since it's based on AWS Zero Trust principle, it gives security teams to have a better security posture. And you can define access for each application using real-time contextual signal at single place. So with a few clicks, you can make policy changes, add new application, and it happens with few minutes, no longer need days or weeks. So this is how it looked like previously, right? You need network team manage VPN policy, developer manage identity, and IT admin to manage device policy. But now it's quite simple. Your user don't need VPN to access application, and you can manage all of your application at one place. So let's look inside Verified Access to see how it works. Actually, it does 3 things. First, you can define access for each application. For example, financial team can access only financial application, right? It improves observability by logging every single request that comes into your application, either allow or deny. So you can use this data for troubleshooting, audit, or compliance. Well, Verified Access, we built it on open ecosystem. That means you can continuously use your existing security services, and it will help you integrate, simplify integration between those security services. So let's talk about our partner roles with Verified Access. We essentially have three sets of partners. First, trust providers, like identity providers, where you can manage a user in your organization. We are working with major identity providers, helping them to integrate with AWS Verified Access using standard protocol. We are also working with device security partners, where you can manage security for your devices. And we also working with contextual data partners who provide contextual signal like location, behavior analytics, and many more. We are also working with partners who consume verified access logs, give you more insights, which help you with troubleshooting, audit, and compliance. And we also have managed connectivity provider who help you build and manage connectivity solutions. Well, these are our partners that currently can integrate with AWS Verified Access. So let's talk about how to set up AWS Verified Access. Actually, it's quite simple. You just need 4 steps to do it. First, you can create AWS Verified Access on the region where your application lives. Then connect it to our partner that I talked about earlier, right? So Verified Access can get the data from them. And you associate your application to Verified Access. You can associate your application, either it running in the different VPCs or different AWS accounts. Well, finally, it's about policy. By default is deny all. You have to write down your policy for your application and define who or which device can access your application. Well, after you have done all of these steps, your user can access your application from anywhere. Well, what happens when your associate application with Verified Access? Let's say we have application running in the VPC on the right-hand side. After you associate your application with Verified Access, what happens is that we create a public endpoint that you can get DNS name and IP address. Then you do the CNAME mapping to map your application name with the DNS name that Verified Access provides, so that your user can access the application with the same name. And then all requests will come to Verified Access, and it will evaluate based on the policy that you defined. So you can add more security by integrating your Verified Access with AWS WAF to protect your application against the broad internet-based threat. And it also supports passing sign identity context to your application endpoint. So let's talk about Verified Access policy. Although we allow you to define policy for each application, right? But imagine if you have 100 applications. You don't want to write 100 policy, right? Our recommendation is that you just group your application that requires same security needs. For example, financial application is in one group and IT application is in another one. Then create a policy for each group and share the policy within the group. But if some application require more controls, you can create policy and apply it into the application level. Well, verified access policy look like? We are using the brand new policy language that AWS built called CEDAR. You can define, permit, or forbid statements with some condition. Let's see some example. First example, we want to permit or allow requests from the user that in the group that contains finance and have overall device assessment more than 80. Next example, we just allow the user emails that in @example.com domain and have Rolex device. Next example, we allow or permit post method. From request from the user in administrator group and their device is already patched. So for the last example, we forbid or deny the request if the user is using unpatched device or untrusted device. Well, when CEDAR evaluates the security policy, it will create an isolated environment for your security policy, right? For example, when request comes in, CEDAR evaluates your request, and if you get forbid, the request is proxy to your target. But if request comes in, CEDAR evaluate and you get forbid. Or if CEDAR has any error processing your request, the request is just simply isn't proxy through your target. Well, let's summarize some benefit of AWS Verified Access. First, it improves security posture with AWS Zero Trust principle, adding more control from non-network based control, keep continuously verify your requests. It improves end user experience. Your user don't need VPN to access your application. And it reduces IT operation overheads that caused by VPN-related issue. It also simplifies your operation when you integrate your third-party security services. And it helps you reduce time when you want to make policy changes or onboard new application. So, after this session, you have learned how to protect your network and how to implement AWS Zero Trust solution. Well, for the next step, if you want to apply it into your organization, you're just starting with align your organization policy with the security framework that we talk about today. Then perform risk assessments and consider which functionality you need. And you have to consider your budget as well and your existing architecture to prepare changes. Well, the final step is the most important. Let's start building. So, if you want to learn more about AWS services, you can visit Skill Builders, our online center, and explore over 600 free digital courses, all hands-on lab, and role-based game. Well, thank you for attending this session. We hope you enjoy it, and we would love to hear your feedback. So please leave your feedback in the survey. Thank you.